would like to present, some of my, so I've been working on smart home and IoT security research in the last 4 or 5 years. And that has led me to understand that the smart home and IoT firmware security attack surface is actually really large. And one of the goals is to improve cybersecurity awareness and workforce development in the smart home and IoT space. And this talk is going to be about that. So I think I'm gonna go over here.
Where do we do that?
Sorry, by the way, this is my first time the hybrid mode presentation, so trying to get used to the interface. Okay, so here's some statistics about the prevalence of smart home devices. Oh, sorry, they're not able to see that part. Right? Okay. So the number of US households that have some kind of smart home device has grown really, really rapidly in the last 4 or 5 years. And today, approximately more than 60 million US households actively use some kind of smart home device. And more than 45% of US households actively use smart home devices on a monthly basis, right? So some examples of smart home devices are smart home appliances, like fridges, microwaves, coffee makers, etc. A lot of baby items like baby monitors, toys, etc. Smart vacuums, doorbells, healthcare devices like insulin pumps, thermostats. These are just some examples. Now, what's staggering is 40.8% of smart homes have at least one device that's vulnerable to cyber attacks. And routers are typically very vulnerable. So what can hackers do with these smart home devices? So for example, hackers can ruin your food by calibrating controls or ordering an excessive amount. They can do things like do unauthorized access to your home by hacking a smart lock. They can actually tamper with the central control of the smart home devices, so mess with the smart hub that can eventually percolate into other devices in the smart home. They can use a smart vacuum, which maps your floor plan and can steal your home's layout information. So that's just a few examples, right? So they can do all sorts of things. Some of them are more simple, some of them can be a little bit more dangerous. So for example, trying to start a fire in a fireplace or opening your garage door, things like that. So these are just some headlines from many different newspapers that sort of show you how we keep seeing increasingly more frequent attacks on smart home devices. So these are titles from articles in the last few years. So what causes, so when we look at this from a cybersecurity expertise point of view, what are some of the things in the smart home that can actually lead to attacks, right? So one main thing is the device firmware. So a lot of these, like for example, smart microwaves or smart fridges, they use something called a system on chip firmware right on the device. And it's a simpler sort of computing environment that can run code, and that can be hacked. And they are typically written in they're compiled for architecture such as MIPS and ARM, things like that. The companion mobile apps that control the device. So if you have a phone or a phone that controls some of these appliances or your garage door and things like that, the attacker can penetrate through the code in the app itself. They can affect the routers and the network devices. They can affect the communication protocols and more. Right. So these are some of the things as what we call the smart home attack surface. Now, while smart home devices are growing so rapidly, and this attack surface is also growing really rapidly, And on the other hand, we see that there's a huge gap in the cybersecurity workforce demand and supply, right? And that gap is growing. So currently, there's an estimated 3.14 million professionals that are needed to fill the cybersecurity gap. And this is the latest statistics from September 2022. Now, the other part of this equation is that diversity and inclusivity, so there's a severe lack in diversity. So right now in the US, only an estimated 4% of cybersecurity workers self-identify as Hispanic, only 9% as Black, and only 24% as women. And as you all know, diversity and inclusion are extremely important for, having varied perspective and creative solutions to solve challenging problems. So some of the reasons for this massive disparity is that a lot of cybersecurity jobs require expensive specialized skills and certifications that many people may not have access to. There's also a severe lack of mentorship and role models that belong to the diverse and inclusive workforce. And there's also an increased media consumption with potential prejudice and bias. And finally, there is systemic racism and hiring discrimination, lower pay, and limited advancement. So these issues have to be resolved in order for us to really meet that cybersecurity gap. So today's talk, I'm going to talk about some of our efforts towards these challenges that I just outlined. I have an NSF funded grant, a cybersecurity grant, cybersecurity EDU grant. So that's been going on for about 4 years now. It's still going, and it's been pretty successful in terms of the number of efforts. And these are all the people who worked on it. In fact, there are more people that I couldn't list everybody on the slide, but we've had some really great undergraduate students, NSF REU students, master's students, PhD students, and very great, collaborators as well who contributed to this project. And I'm going to mainly talk about the efforts that have sort of stemmed from this project. I would especially like to give a shout out to my co-PI, Harini Ramaprasad, who's been a very integral part of this project. And she has really brought a lot of the CS education research background to this project. So our project is called eShield, Enhancing Security Education in Hybrid Mobile and IoT Firmware through Inclusive, I'm not able to read that, I don't know, sorry. How do I, through inclusive, engaging learning modules. So this pod chart sort of depicts our overall plan for this grant. So here on the left hand side of the upper left quadrant, this is our proposed work on creating engaging and inclusive education modules in two spaces, hybrid mobile app and IoT firmware security. And these courses are designed as stackable modules. So instructors, and we intend to share this, and the courses can either be taught completely, in full, or instructors can choose to pick modules and insert it into their courses as they see fit. And many of these modules are designed as the NSA DHS knowledge units, which can be inserted into NSA DHS Center for Academic Excellence requirements for courses.
Can you pause?
Yes.
Your slides are not showing, they're not advancing.
Oh, really?
They're advancing on your screen, but they're not advancing on.
Which slide do you
Zoom.
see?
We see the intro slide.
Oh,
And
really?
I think it's because you're in present or whatever that Apple thing is.
That swap.
Oh.
Is that? There we go.
Ah,
Yeah, and then
That's
just
what you
click
see
that
now.
little yellow, that little green thing up there, then you'll be able to, if you click that, it should, now you'll
Okay.
be able to see.
Okay.
thank you.
Thank you
Swain.
so much. So you're able to see the.
Now it's like, now they can see.
Okay. Sorry. Okay. So and I need to move this now. Sorry, technical difficulties. Okay, So the second quadrant, the right upper quadrant shows sort of our high level pedagogical goals and strategies. So we really want a flipped classroom environment, and it's great that Celine's here today, so we can actually refer to her. And so a lot of interactive and engaging, pedagogical techniques, and evaluation, both in terms of the student evaluations themselves, and then evaluation of our learning content and broader impacts. We also, another important goal for us was to be able to provide virtual lab support. So a lot of work on IoT security requires a physical device, and we started this project when it was the pandemic, and we really wanted to be able to have modules and lab support for students who wanted to do this, in an online mode. And so being able to have things like emulated environments for IoT devices that can be provided as part of virtual lab support. And then the third quadrant, which is the right lower quadrant, is our outreach program. So we really want to disseminate our final course modules through Creative Commons. We have plans to do faculty training at North Carolina universities and community colleges, especially the HBCUs. And we've also been working with local middle schools to do a K-12 IoT roadshow and cyber awareness activities. And we also are leveraging our CCI Smart Home Lab in order to do some of these outreach activities, and also use the lab to sort of promote, the lab is open for any students or faculty to come in and either use the equipment and the books and the resources for designing course modules, or to do research or any of that. And the final quadrant, which is the left lower quadrant, is about research. So our goal is to use the results of our teaching experiences back into research. So for example, I'll talk briefly about a class source penetration testing of IoT firmware, in which students discovered vulnerabilities in IoT firmware in class, and then we could sort of plug that back into research and look at how to exploit those vulnerabilities, how to create test beds and things like that. And finally, we want to connect the results of the research back into education. So we really want the education to be very cutting edge and use the results of the latest research so that students can really have experience with the state of the art. So this is the overall goals of our project. Now, I guess I'm not able to use the clicker.
You want me to click for you? Let's see if I can do that.
Are you in Zoom as opposed to Within?
Probably. Where are you presenting yourself?
PowerPoint.
It's right there. What did you do to get her here, Celine? Do you know? Oh, wait. Here we go. I'll drive. talk.
Okay. Let me, so it doesn't work? No.
Did it work now?
Okay,
Oh,
perfect.
good. Okay.
Thanks everyone for your patience. And they're able to hear me on the Zoom, right? Okay. So I'd like to talk about a few different projects. So our eShield project has actually led to a lot of different sub projects and efforts, but I'll present a few here that are sort of some of the main ones. So the first one is a suite of POGIL, or process-oriented guided inquiry learning style guided learning activities, which teach foundational concepts for learning an attack called a stack smashing attack and defenses for that. DISAB, which is a program visualization tool for teaching stack smashing attacks. Criminal investigations, which is a gamified, scalable, web-based framework for teaching and assessing IoT security skills. A small project on class source penetration testing of an IoT firmware router, which is a great example of connecting teaching back into research. And then two separate efforts on the education, on the K-12 education front. So the first is the suite of guided learning activities. So the scholarship on this is, we have one paper in submission right now, and one of the activities has been cleared by the Fogel group. So it's an official Fogel activity, and the rest are on submission right now under review. So let me tell you a little bit about the problem and the motivation for this work. So a stack smashing is a buffer overflow attack, which is highly prevalent today in the cybersecurity environment and very prevalent in the smart home system. So for example, we've had a vulnerability that's been extensively used in a lot of smart home routers, for example. And we constantly see stack-based attacks happening in different firmware of the smart home environment. So just a little bit of background about how the attack works. So basically what the attacker does is they overflow a buffer in the victim machine to override critical memory components, specifically the return address of a function that's placed on a call stack. And they're able to leverage this to redirect program execution to malicious code. And this is a very powerful attack because the attacker can actually redirect program execution to run shellcode on the victim machine. And once they can run shellcode, they can then do anything they want after that. So it's extremely powerful. It's very popular, it's used mainly in memory unsafe languages such as C. So C, enables this to happen. And a lot of my students ask me, so why do we have to learn C? Because, C is such a legacy language. And here's the thing, a lot of IoT firmware are written in C. And the really, interesting and sort of weird thing is that, so for example, router firmware or different other firmware, what people do is they take legacy code that's written for traditional systems, such as like a network management software, and simply just recompile it for IoT architectures and deploy them, right? So what happens is a lot of IoT code, which is very relevant today, is written in C and carries all the vulnerabilities that were there in the traditional systems, And as we all know, people are not very good at patching their systems, so those vulnerabilities still exist. So that's why we see a lot of these stack smashing attacks in IoT, and like I said, in the smart home environment. So that's the problem and the motivation. That's the motivation. Now, the problem is, so we really ideally want to equip our students with being able to, understand what a stack smashing attack is, our cybersecurity students and others, if they're interested, and also how to defend against these, right? The problem with teaching stack smashing, and this is from my own experience, teaching software security modules or software security courses for the last several years, is that it's a very sophisticated attack. That's hard, it's abstract and complex to understand. It requires, at least some minimal knowledge of C, which is, difficult for students to grasp in general. And it also requires vast background information, like lots of different moving parts. So, for example, how the memory of the process memory is structured, how parameter passing works in C, how the stack works, and things like that. So it's a lot of concepts, and it's challenging. So how can we make this a little bit more appealing to students? Was our question, and that's the problem and motivation. So in this project, what we designed was a suite of guided learning activities, where instead of the instructor, so for example, me just lecturing the students for a long time about all these different components, which doesn't, it's not very effective. They sort of self-guide themselves by the style of the questions, and they start discovering concepts by themselves. So we have designed 5 of these activities. So if there's a warm-up activity, which is strings and C and command line inputs, etc. Activity 2 talks about buffer overflows. Activity 3 talks about process memory layout. Activity 4 is on the stack smashing itself, which kind of puts together all the information from the previous activities. And then activity 5 is defenses. So here the students explore learning models that depict the relevant information, and then they proceed to invent the key concepts themselves. And after that, once they've done all the activities, then we sort of discuss as a class on what they learned, and we have this discussion. And so this has been pretty popular. So in this work, formally though, we seek to answer these research questions. So do students think that the guided learning activities are well designed and help them learn about stack smashing? Do students think that the guided learning activities are engaging? Do students across multiple age groups, genders, and prior experience in areas related to stack smashing have similar perceptions about the guided learning activities? So these are just some examples. So this is a question and a diagram from the warm-up activity. This is a question from the buffer overflow activity. So this one is a model from the process memory layout activity. So we have a lot of colorful pictures, things like that. And by the way, these active, just as a interesting side note, a lot of these diagrams and questions were actually designed by an NSF REU student who took my class, 3200 class, Info Security and Privacy, and then later on did an NSF REU with Ernie and me, and he actually drew a lot of these diagrams and framed a lot of the questions. So that was pretty cool. So this is the stack smashing. This is a picture from the stack smashing attack activity, and this is from defenses. So our study methodology is we have Likert scale questions that gauge student perception of length, challenge, style, outcomes, engagement, and team role usage. And then we have a free response question that asks students to give any additional feedback. And then we have the demographic questions to give their age, gender, and indicate their experience with the C programming language and stack smashing. And we had 17 Likert scale questions, 1 free response section, and 4 demographic questions. So we deployed this last semester, so 2 sections of 3200, which is a junior level undergraduate introductory cybersecurity course in fall 2022. And this course introduces a broad range of cybersecurity topics, and it's a required course for a large number of students in our program. So both the classes together had a total of 90 students, and 77 students completed the voluntary survey and consented to have their responses collected and analyzed. So we're pretty happy that such a large percentage volunteered. Like I said, the questions were structured into these groups. So activity structure and outcomes, activity length and challenge level, activity style and engagement, and team role usage. So this is sort of what our questions, look like. I'm not getting into the details of that, but the conclusions, and I can, go into the details if somebody's interested, but the general conclusions were that the structure of the study of the activities and the design were positive. The sufficiency of teaching activities were sort of neutral, whether the style of the activities were engaging or split. And generally students younger than 25, and those that had prior experience with C had better perceptions of the outcomes. So that's what we found. And of course, though, we are in the process of revamping and then redoing it. So we're going to take some of the feedback. And then apart from the actual study, I also had a lot of students come to me after the class and indicate, what they'd like to improve and things like that. So we are going to improve and redeploy it. So the next project, which is sort of related, but a separate project, and this was actually a master's thesis. So it's called DISAP, a dynamic interactive stack smashing attack visualization. So this is about using program visualization techniques. And this work was published in two different papers. So the first one was the tool itself, and actually won the best paper award in the Journal of the Colloquium for Information Systems Security Education. And the second one was more about the deployment and additional data and things like that, and then publishing the results of the data analysis. And that one was actually just accepted into CISSE. So the goals of this app, the high level goals are to increase student engagement and learning in advanced cybersecurity topics. Motivate students to study buffer overflow attack in more depth and promote the use of program visualization tools for advanced cybersecurity topics. And this, I just see this as the beginning. You know, I'd really like to see program visualization and tools like this used more, because a lot of the advanced cybersecurity topics are sort of difficult and drab. So it would be good to see some kind of pictures and things like that. So this app is a program visualization tool for teaching stack smashing attacks. It's a web-based application built with React.js. So it has a certain workflow which allows students to create a simulated attack scenario. So it sort of complements the guided learning activities, because here they actually sort of play around with the tool and then construct a stack. So the three parts are, creating a function, constructing a payload, which is the malicious code, and then finally executing the program to conduct the attack. So the features, the app features are that it's interactive and engaging. So using colored fonts and icons and buttons to improve student engagement and also appeal to a broader and more diverse student audience. It also provides, to some extent, the ability to customize an attack scenario so that students can sort of think about the end goal, and provides guided incremental steps for completing the attack. It also provides dynamic visualization, so it sort of displays the current state of the call stack during program execution, and helps visualize memory addresses and sort of like what's happening in memory. And currently there are tools, that cybersecurity experts use, like GDB, like a debugger, to look at the memory, but it's very, it really requires an expert level of knowledge to be able to use those kind of tools, so it's not reasonable to expect students in an undergraduate class without any experience in using these kind of tools to use that. So this one provides a more simplified interface for interacting. So it also highlights various parts of the program code itself during execution. So, sort of students can kind of see, okay, this is the part of the code that I'm seeing on the stack right now. And it allows students to customize vulnerable functions. So, so they have like end goals, like start a remote shell or wipe the OS. So it kind of gives them a tangible result. So these are just some of the sort of screenshots, and I was thinking that maybe I should have done like a live demo or something, but maybe for next time. But this is the create a function part of the workflow. So students can sort of add different functions and like local variables and parameters, things that are needed for the attack. The second one is constructing the payload, so the different parts of the payload that kind of go into what the attacker puts into the program. And then, finally executing the program. And so they have these colorful buttons, and, they can see whether the attack was successful or not. And this is the dynamic visualization. So they have these different, so they can kind of see the stack at a very high level, but then they can sort of zoom into each part of the stack and see more details like this, for example, and kind of see how the memory addresses are laid out. And this is really important for the attack, because the attack, so for the attack, the attacker actually has to calculate like how many bytes they have to override on the stack. And that's really hard to visualize, if you don't have something like this. So here they can actually see that, and they can see, oh, you know what, if I override these 16 bytes, then I reach into a region where I can override the return address, for example. And this is the visualization of the program. So these, like, for example, if you're in May, that part of the program is highlighted. Students can kind of navigate. So we have kind of similar questions that we posed for the guided learning activities as the research question. So we have some questions on student learning and some questions on student engagement. So this was actually deployed in 2 sections in fall 21 and also in fall 22. Same again, the introductory cybersecurity course 3200. The fall 21 had 104 students and only 26 students completed the voluntary survey. So last year we had a bigger group of students who volunteered. But in general, and again, this is also through anecdotal feedback that I got from students, the students really like it, but here's the data. So the blue is positive results, red is neutral, and yellow is negative. So these are the student learning results. So this is distribution by age. This is distribution by C experience. This is by stack smashing prior experience. And this is by prior program visualization experience. And again, I can zoom into the details later if someone's interested, but in general, you can see a lot of blue. So, so students mostly had positive feedback. And these are the student engagement results. And again, a lot of blue, and neutral and some yellow. Okay, so that brings me to the next project, which is quite different. So this is called criminal investigations. And again, we've had several students work on this project. So this is a gamified, scalable web-based framework for teaching and assessing IoT security skills. And this kind of connects back to that virtual lab thing that I talked about earlier in terms of one of our goals for the eField project. So this sort of is a framework in which we can just constantly add activities and students sort of work through the framework to understand different parts of how to do IoT security. So this was first presented as a poster in SIGC in March 21, and then later on published in SIGC in March 22. So again, similar goals. So basically, we want to try to teach IoT security in an engaging and inclusive way, and also have accessibility to the teaching tools and broader dissemination. So the design is, so we try to promote student learning by incorporating elements of gamification into hands-on activities and interaction. We really focus on interactivity being the most important element in making the games and activities engaging. And this criminal investigation is designed to be used in conjunction with other learning content like lectures, readings, and tutorials. And we want it to be accessible to students from diverse backgrounds. So these are just some of the screenshots from the game. So design features. So we try to have a narrative for all the activities. So we say, this particular laptop was discovered, in the parking lot of UNCC, and it's been hacked. And so what do you do next? And there's a narrative. There are also game modes. So we have a practice and test mode, so students can sort of do the practice round first, and then do the test round, which is the one that actually counts. We have knowledge checkpoints, so to assess student preparedness. We also have just-in-time learning content. So we have the activities, but we also have like these little pop-ups that show up, giving little tidbits of information, so that students don't have to learn a vast amount of information before starting the activity, because that's hard to retain. And then we have these experience points to keep students motivated, so they earn these, and we're, again, this is sort of a prototype design, and we're constantly working on it. So we really want to add things like badges and things like that, and more gamification stuff that keep students interested. So the current implementation that was published in 6C22, it uses a React for the user interface and front end, and a Python Flask library for the back end, and MongoDB for the back end database. And it's deployed on a UNC Cloud server that runs Ubuntu, and it's accessible to students on campus or through a VPN, just through a standard web browser. And all the tools and files required are given as a pre-built VM image, so that it's just easy to use, so that it start work. So this is just our first activity, and in fact, this is not even a real cybersecurity activity. It was just, a sort of a prerequisite activity that somebody might have to do in order to get cybersecurity stuff. So in this one, the student sort of just reverse engineers and analyzes an IoT firmware and tries to discover different components of the firmware. So just sort of understanding what the firmware is about. So like the compression scheme, the kernel, the bootloader, just identifying different things. So it's there's a compelling narrative that places the student as an assistant investigating the campus IoT hacking incident. And as I said, a lot of the tools are already installed as a pre-built VM. So this was deployed in spring 21 as an extra credit module in one section of UG early graduate game design and development class, and also 3 sections of an undergraduate OS and networking class. And we had these pre and post surveys, learning content, prototype activity, quiz, and voluntary feedback survey. So the general student feedback indicates that our framework is engaging and accessible. So again, these are just, so we have these questions divided according to the user interface and accessibility. And as you can see, generally positive student engagement, generally positive student learning. And then we also had pre-response questions. But we're actually working pretty hard on creating we have several ongoing future work for this project, because we really want to do a refactor framework, but also add activities, and it's extensible, like I said. And also, do things like increase randomization and adaptability and using concepts of artificial intelligence. Okay, so I just so talking about the next effort. So this was a small project about class source penetration testing. So this was an interesting experience. So this was part of a graduate security class that I taught, and what we did was to take an IoT smart home router, basically, and design a project for the graduate students that had 3 phases: a network security, a web security, and software security. And so what the students had to do was, one of the tasks was to discover vulnerabilities in the firmware, and they did. So they discovered two vulnerabilities, and I was very surprised. So 2 previously unknown, undisclosed vulnerabilities. And that was super impressive, I thought. And so we actually reported the CVEs to the Common Vulnerabilities and Enumerations Database, which is like the standard in cybersecurity. It's a database of all exposed vulnerabilities. So we did that, and that was actually presented in the IoT workshop on the Internet of Safe Things in 2020. So that was one way to sort of think about how connecting the education back into research. So just want to talk a little bit about 2 K-12 cyber awareness activities. So this one is, so again, our motivation for this was, sort of connecting back to my original motivation of the smart home attack surface. So we've been thinking about 2 things. So one is, in order to promote more interest in cybersecurity and also to promote more diversity and inclusivity in the cybersecurity workforce, we need to start early, so as early as possible. So right now, I think in middle school, but I think eventually, it would be good to think about elementary school as well, and think about how to so with a lot of these smart homes now, there are people, especially what I call the secondary users, not the primary users, but secondary users that live in a home that has become smart. So, for example, little kids or the elderly who may not be very tech savvy or may not understand the repercussions of an attack, are thrust into a smart home environment, right? And so it's really important to spread this awareness. So both from an awareness perspective and for the cybersecurity workforce development, it's important to have these activities for those demographics. So in this one was about thinking about what is a secure password. And I always talk about this in my classes, but one of the most common passwords in use today is the word password. So that's still very prevalent, right? And with a lot of the smart homes, so the Meera botnet attack happened in smart home systems because people didn't change the default username and password on their smart home devices. So sort of motivated by that, this activity was sort of teaching students, teaching middle schoolers about, like various activities through games about how to create a good password, like what makes a good password. So how not to use, things like name or date of birth or, a favorite pet and things like that.
Oh, God.
I'll share my screen. Oh, okay. Oh. Oops. And this activity is about how to identify phishing email. So an email that looks very legit, but it's not. It's really intended to, get some sensitive information. So how to teach middle school children about concepts, passwords, secure passwords, and phishing emails. And so what we would like to do is we're actually working with Alicia Moss, a teacher and a Cuban fellow at the J.M. Alexander Middle School. And we're working with them to teach these activities for 8th graders. We're hoping to do this in fall 2023. And we also we've constantly been organizing different hosting different school groups at the Smart Home Lab. But we also want to sort of have more sort of organized sessions in which we can do activities for middle schoolers in the Smart Home Lab. So that's the goal of that. And finally, this last project is about a games-based approach to cyber education for K-12. And this work is actually in collaboration with Audrey. So this is a grant that we got from the Gambrel Faculty Fellowship, and it's with Julio and Audrey. And this one is similar in its goal. So we would like to teach middle schoolers or school-going children about basic cyber awareness. And this one is through a multi-scenario game. And so we really want to target communities for economic mobility. That's the goal of the grant, and address lack of access to technical careers, so by promoting some kind of interest in CS and in cybersecurity. We are also planning to deploy this in CMS schools for K-12 students. And one of the main goals of the game is to have it be playable without any high bandwidth or expensive hardware, so anyone can access it. And eventually, we also plan to deploy that in 2 languages, English and Spanish, again for broader accessibility. So these are just some scenes from the mini games that we have. Role-playing game, and we have 3 games. Yeah, secure web browsing, phishing, and cookies. And we've had some really great students work on this, so thinking about what are some concepts that middle schoolers should know about secure web browsing or phishing or cookies, and how to make that very appealing. And we've had some great UNC Charlotte arts and digital media students sort of depict this. So for like a cookie, they have an actual cookie and make the game really fun and interesting. So that's what that project is about. That brings me to the end of my talk. Thank you, everyone, for we have questions from our audience members. I can chat or okay, Joshua, you have a question? Do you want to type it or you want to unmute it?
Okay. Yeah, thank you, Audrey. Thank you, Dr. I apologize. I don't know how you say your last name.
Don't worry, Sridhar.
Sridhar. I have a very great, thank you for the great presentation. I have a question. It's related to your presentation, but not so closely. I'm curious to hear your thoughts on the relationship between math and the areas of expertise areas within this CS, like the content you just presented. Like, what's the connection between them? In other words, do students have to have a very strong mathematical foundation when they get to college in order to move on to pursue these areas of computer science specialty, I guess, maybe specialty areas? Because I saw your approach to K-12, that was great, but I'm just curious about the connection between math and the CS, particularly this area of specialty area, and what it means to broadening students, that they can not only at the K-12 to have a fun and exciting exposure, but they will be able to move on when they get to college and then maybe be beyond college. Thank you. So,
Yeah.
so in other words, we want, in terms of broadening participation, we don't want math to become a barrier, but also I'm just wondering if math also might be or might not be critical for this specialty area. Thank you.
Thank you so much. That's a great question. So I was thinking about it, as you said. So it depends a little bit on the sub area of cybersecurity. There are parts of cybersecurity that probably don't need too much math background. But for example, in some of the intro topics that I teach, things like password security, for example, do require some math background. Cryptography definitely requires a pretty strong math background. The stack smashing attack that I talked about, requires things like hexadecimal address manipulation and things like that. But there's also, your question actually aligns a lot with what I've been thinking about, which is slightly different from this talk, which is on formal verification. So formal methods or formal verification is a way to prove that a certain piece of software or a system adheres to a security policy. And that's a very critical piece that may not be, there may not be too much awareness of that outside the cybersecurity community or at the undergraduate level in the general population. But, it's becoming increasingly critical, especially as we move towards things like critical infrastructure becoming, networked, right? So just as or if you've heard the term cyber physical systems. So for example, I'm also, as part of my research, I'm working quite a bit on power grid security. And, one problem that we've been looking at is the power grid is becoming increasingly consumer based, right? So if you think about things like electric vehicles or, solar panels. So the end user has control over the power, basically, because they can feed back into the power grid, and things like a botnet attack could really influence a blackout. So for that kind of work, especially, we really need formal methods to be able to have some kind of high assurance. And the biggest challenge that I'm facing right now is the math barrier for students to learn the background, because it requires things like mathematical modeling and set theory and discrete mathematics, and of course proving things. So that's something I've been thinking about a lot. And actually Harini and I have been, Harini Hai and Julio are currently working on an NSF grant proposal on precisely this, how to bring some innovative pedagogical strategies to make that math barrier easier in formal methods work. So I don't know if I answered your question.
Excellent. Thank you. You answered my question perfectly. Thank you.
And I'd be happy to talk more about that offline.
Sure, great. Yes, thank you. I work closely with Audrey in this lab, but prior to finding Audrey, which is count that as a blessing, and connecting the dots was Steve Jobs said why I'm here. But anyway, yes, because my interests, I was trained as a applied methodologist in social science, but I'm always interested in foundational math education and also the implication of math for STEM participation. So then in recent years, my work has moved a little bit away from K-12, but I have two elementary kids who love computer science. That's why I'm here. But so in other words, even though I moved a little bit to look beyond the K-12, but it's always hanging in the back of my head in terms of broadening participation in CS, what role math play in terms of being a facilitator or hindering factor, and what can we do about it? What are the solutions there? So thank you.
Thank you.
I'm
Thanks.
going to be quiet for now. Thank you.
Xiaosha said, because I was gonna introduce Xiaosha. She is working on projects that train K-12 teachers. So, and we're working together with some others on trying to get funding for a teacher certificate program for CS principals, and they could deploy the lessons and games that you're working on developing, but they need training on how to do that and what
Right.
those core concepts are. So I think it's could be an interesting relationship in the future.
Yeah, I'd be very interested. Also, when Xiaoxia mentioned her elementary school kids, I also wanted to say, so this is something I've been thinking, right? An idea, and this is a great place to bring this idea up in the CEIR forum. I want to know what people think. So, me and Harini were having this conversation on how early should we start, right? Like the cyber awareness.
Right.
And as you know, Audrey, I have 2 kids in daycare. And they're really young, right? They're like 3 and 1. And they play with my smartwatch, they play with my phones and things like that. And one thing that me and my husband are worried about is, what if like they just navigate to something and there's a hacker or whatever. I have no idea how to even go about this problem, but that's an interesting thing to just think about, right? Like that could be some potential ideas there.
It certainly is, and how to train parents on protecting their home environment and their children when they are more sophisticated in many ways than their parents.
Yeah, definitely.
I put myself in that bucket.
Yeah.
And to make sure that nothing bad starts to happen with what all they're able to do.
And like smart TVs are something that they interact with a lot. Yes.
Going back to the math that you were speaking of. So when you have an environment where those higher level math classes aren't offered, I mean, what do you recommend for students who are interested but feel have a math intimidation? Or if they do have those higher level math classes, where do you think in high school they should start?
That's a good question. So the first part of your question was how to make it more engaging. Is that what you were asking?
If they don't have it, like, and they feel, well, all I got to was maybe pre-calculus in high school. And is that going to be a good enough basis for me to go into this or come out maybe feeling intimidated? Because one of the projects I work with, the STARS, we see a lot of people leaving the major. And then they came scholarship. They left the major, but I'm wondering a lot of it. I would like to maybe do an exit survey to see if they're leaving the major because they're intimidated by the math. Or found something better they like, it's college. But I think that myself, I was in school many years ago, the highest I ever got was pre-calculus and I did not do well. So I would have never gone into college thinking I could do a math-based major. So how do you overcome that where maybe I could have, but I just had that math intimidation?
Yeah, I'm thinking that it'll be good to have some kind of, supporting kind of activities and coursework or modules that they can do, so even after they come to college. So for example, they feel that I'm interested in this, but I have this barrier. So I think we'd have to work on creating those kind of engaging modules that that is readily accessible to students. And I think that's the biggest challenge right now is the accessibility, because I can just imagine, right, like going to some of this, where do you start? If you want to go online and like start, tutoring yourself, where do you start? How do you know what exactly is needed? It's a vast ocean of work. And I think it'll be good to have some kind of support framework and that students can do outside. And I think math is something that it really, again, I can speak from personal experience. It matters so much who the teacher is and what the teachings are, right? Because I've had some really bad math teachers and I started dreading math, and then I had like great teachers, then I started loving math. So,
We have a question from the chat. Do you have a link to your C program tracing or memory leak detection?
The education modules or the research? The DSAV, you mean, Jung?
I think that it is, I'm not sure it's educational, and I just came in the second half of this meeting.
Oh,
And that is a web page you mentioned, the student can, they can click and to say to.
yeah, the DSAV work. Yeah, I can send you a link to that.
Oh, that's great, thanks.
I think we're out of time.
Okay, yes.
So thank you so much.
Thank
for a
you.
Really interesting talk.
Thank
A
you.
lot of important work happening.
Thank you.
In your space. And so thank you for sharing that with everyone. And we will release the recording on our website following the meeting. Thanks, everyone.
And yeah, and if, I'd be happy to answer further questions by email, and, I'm always open for collaboration, with this group as well. So think of me, please, when you want to collaborate.
Thank you.
Thank you. Bye.